Thank you for coming. If for some reason we cannot fully cover a programming language in 10 minutes, come to office hours. I'll be here at 11:20. So come and ask questions. So let's get into it. What is Kotlin? Kotlin is a language developed by JetBrains. They develop a lot of tools. IntelliJ, ReSharp are a lot of developer productivity tools that are really high-end. So they have a lot of expertise with working with software developers. It's released under the Apache 2 license, so you can go and commit changes to this language. I mean, there's a process to it, but you can go and do it. It's a really open language. They really welcome people thinking about it. There's a very detailed process for contributing. It's designed as a general-purpose language. Now, you might have heard, like, oh, it's good on Android, or it's good on this. But it really is developed to be a general-purpose language because it targets Java 6, Java 8. You can target JavaScript. You can target all sorts of native platforms. You can target iOS if you want. So that's part's in beta. But the beauty is that you could have a set of models or a set of behaviors and write them in one language and have it behave completely the same on all of those platforms. And from the start, it's been designed to avoid entire classes of defects. It's trying to make things that are bad or not optimal. It makes them hard to do or makes them impossible to do. And by that, I mean there's things like null safety. So if you come, like I'm a Java programmer before I was a Kotlin programmer, you don't think nulls are a problem in Java. You go look on GitHub at how many people have complained about null pointer exception, or how many people have asked the what is a null pointer exception and how do I fix it question on Stack Overflow. It's 100% interoperable with Java. So if you have, there's 23 years of languages, of Java libraries that you can pull right in. You don't have to change them in any way. They just pull right in. You can use them completely seamlessly. And the language itself is pragmatic. When I look at some syntax with you, you'll say, hey, that's stolen from Groovy, or hey, that's stolen from C#. Yes, it totally is, because that's okay. They're taking what's good from other things and rethinking them. So it's like one of the things you hear about Kotlin is like it's a better Java. I mean, and it's true, because they're taking the things, the benefit of hindsight of 20 years or so, and saying, what would we have done differently if we could have done it then? And you'll see that throughout the language. So the go-to book in Java for how do I write good Java is Effective Java. And I'm not going to go through all these, but this is just the one I skimmed my copy the other day, and I thought, wow, this is really interesting, because none of these things are possible in Kotlin, or these things are just completely avoided. Like, I don't have to go out of my way to code around them in Kotlin like I do in Java. So one of the things that when I pick a new language or library, I like to have some herd immunity. I don't like to be the only one out there with it, because I just don't. So I'll just mention this, that Android recommends that you use Kotlin now. Top 1,000 apps in the Google Play Store, 25% of them have Kotlin in them already. And if you're a Java backend developer, you know about Spring. Spring Framework is probably 50% of the Java backend market. It's fully supported. It's Kotlin. It's well integrated and has great buy-in from that team. So you're not alone when you're using this. And so we're software developers. Let's look at some syntax. Let's start with variables and values. So variables mean something can change. Values mean it can't change. So in this case, I've got a place. It's a type string. It says Chicago. It's a variable, so I can say I can reset that to Austin. That's totally fine. On the other hand, I've got this value, which is my name. But if I set it to my daughter's name, I can't do it. The compiler won't let me. Okay? What I really want you to look at is these types here. Now, it's pretty obvious that we're looking at a string in both cases. So in Kotlin, I can just leave those off. I don't have to put them everywhere. So that's a lot less noise, a lot less visual pollution. The code is still getting generated the same. The bytecode or whatever we're generating to is still precisely the same. Types are still there. It's just inferred. I don't have to talk about it if I want to. So the big feature in Kotlin is null safety. So let's see, we have this string called name. It's not allowed to be null because it's just not. I can't ever set that to null. On the other hand, city, because it's got a question mark on the end of the string, I'm allowed to set that to null. Now, nulls aren't really the problem. It's allowing programmers to chase a null reference that's the problem. So Kotlin gives us some tools to deal with that. And if you're coming from other languages, this might look familiar. This is the safe traversal operator. So in the case that city is null, I can't call two uppercase on it. It won't let me. That whole expression will evaluate to null. Now, if I did that in Java, I'd get a null pointer exception. So pairing that with the other operator, which is Elvis, and it's called that because apparently if you turn it on inside, it looks like Elvis. And I'm like the only person in the world who doesn't see that, but hopefully you do. So if the left-hand side evaluates to null, just pick whatever expression is on the right-hand side. And this can be arbitrarily complicated. I have a simple example here. But these are the tools, the simple little tools that Kotlin gives you to avoid this null problem, like the types that are not allowed to be null and the tools to work with nulls. I'm going to show you this switch thing here, or this when thing. This is like Kotlin's version of switch. So Java's version of switch was pretty much a copy of C's version of switch, which is really just a jump table, right? And it doesn't do much. It's just like a lookup, and you go to a piece of code and run it. In this one, it's an expression. It can do all sorts of things. I'm not going to go through. And so it's like a nice step forward from Java. But if you're comfortable with Scala or some other languages, it's not quite as powerful as those. It doesn't do pattern matching. It doesn't do a couple of other things. So I think this is a really good example of where Kotlin's trying to be pragmatic and say, these are nice, beneficial things, but it's not taking everything, because it's not going to be hard to read or hard to comprehend for a developer to come into it. And that's one of the things I really like about Kotlin, is its ability to say, this is going too far, we think, for now. We want to keep this easy to read. Like when I pull up other people's Kotlin, I find it a lot easier to read than some other languages. So let's go back to Java. We'll write a POJO. It's a plain old Java object, right? I've got this person, first name, last name. That's good, right? We can just check that in. Nobody's going to complain. Nope, I need first name. I need all the setters and getters. So I'm going to get my editor to write me setters and getters. And then I'm going to get my editor to write me equals and hash code, and then I'm going to get my editor to write me constructors, and then equals and hash code, and then two strings. And when we get to this point, I've written 3 lines of code, right? And my editor has written 47 lines of code. And the other problem with this is when somebody pulls this code up, they have to inspect it to make sure I'm not doing something stupid, and one of the getters or the setters, like two uppercasing something, or things like that. There's a mental cognitive load that comes with this kind of thing, when in reality, we just want a first name and a last name. So in Kotlin, we've got this thing called a data class. It's the same thing as I just showed you. It's got a first name and a last name. It's got a toString. It's got hash code and equals. It's got getters and setters. And it's got copying instructors. All of this are just built in for me. If I want to override them, I can override them. But when we have this contract, I just want a person with a first name and a last name. It's simple. I can just look at it, and I know there's nothing weird going on. Now, if we do want to add something, we do want extra behavior, that code will be in there, and we'll look at it, and we'll see it. So you're only looking at things that are not adhering to the contract that we're entering into, right? I don't have to inspect every POJO that I pull up to make sure that somebody's not doing something weird. Extension functions are another interesting thing. I'll just breeze through this really quickly. We've all been here in Java. I wish there was a method to do this, so I'm going to have a static thing. In Kotlin, I can pretend there is. I can write this extension to say, like, int now has an isEven method function on it, and I can call it on int, called to.isEven. Now, I'm not physically changing int. It's just an int scope, and in fact, the code that is generated is the same as the Java code if you look at the bytecode. But it's a nice little thing to make productivity interesting. The code that you're calling looks a lot better than call isEven with 2. You can just say 2.withEven. These little things, they add up. Like, there's no new keyword in Kotlin. There's no semicolons. There's one method for structural equality. In Java, you've got equal for primitives and dot equal for objects. All of that is gone. In Kotlin, you just say double equal. It writes the right code for you underneath. It knows what you're talking about. These things all add up. Like string interpolation. I don't have to add strings together anymore. I don't have to worry about escaping things because I've got raw strings. If I have SQL queries or regexes or JSON, I don't have to worry about escaping any of that. This reduces bugs and increases clarity in the system that I'm developing. And one thing about systems that I'm developing, I don't like developing them with communities that are negative. So one of the things I really, really, really appreciate about Kotlin is how overwhelmingly positive the community is. And this is something the community takes pride in. So if you go into the Kotlin Slack, there's nearly 20,000 people there. The people who designed the language are there answering questions. People who write it every day answer questions. So one of the interesting facts about Kotlin is Stack Overflow did a survey about a year ago. What languages do you want to work with and not want to work with? And Kotlin was the second least disliked language on the survey. And I blurred out the others because it's like completely irrelevant that PHP is the most disliked language to work with. So if you like what I've said, go to play.kotlinlang.org. You can go in your browser. You can open up right now while I'm talking. You can play with Kotlin right there. It'll teach you Kotlin right there. So the title of the talk is Why is Kotlin right for you? I'll answer the question first. It's right for me because I write far. Yeah, that sucks. I'll stop moving. I write far less code in Kotlin than I do in Java. My boss isn't paying me to write code. My boss is paying me to provide business value. So what I'm writing is business value, more directly related to business value. And the code I'm writing is way more expressive and clear to myself and to others. I avoid whole classes of defects. It's just more fun. I just enjoy writing it more. And it really plays well with the tools that I already have. I'm lucky in that sense, so it plays well with what I already have. So is Kotlin right for you? Only you can answer that question, and I hope I've given you the tools to do so today. Thank you very much.